From here, we want to write the equation of the median. Well, your median, again, you want to identify what you're looking for first. So your median goes through the midpoint and through the vertex. Okay, we're looking at vertex A. So first thing is I'm going to go ahead and note that point A is at -5, 3. Now I need my midpoint, and it's my midpoint of the opposite side. So I want the midpoint of side BC. Well, this one's really easy because it's a horizontal line. Well, if point B is at the ordered pair -3, -3, C is at the ordered pair 1, 2, 3, 4, 5, -3, then I can see that the difference, the x, y stay the same, the difference there is 8. So I'm going to count 4, 1, 2, 3, 4. My midpoint is going to be right here at 1, -3. So if the midpoint is at 1, -3, the first thing I need to do is find the slope. Okay? Because I need to find the slope of line AM. Because that's going to be my median, right? Well, the slope, if I go ahead and label this x1, y1, x2, y2, I can plug into the formula m equals y2 minus y1 over x2 minus x1, and I have -3 minus 3 over 1 minus -5. Minus negative is plus a positive. I have -6 over 6, which is -1. So my slope is -1. Now I'm going to choose one point. Okay? Choose one of the points. It doesn't matter which one you choose. Okay? Pick the easier one. I'm going to go ahead and pick 1, -3. So my ordered pair is 1, -3. Now, the third step is going to be plug into point slope form. Okay? Plug into point slope, which is y minus y1 equals m times x minus x1. So I'm going to go ahead and plug in. This is my x1, y1. So y minus y1 is -3 equals my slope is -1 times x minus x1 is 1. From here, I can go ahead and solve the equation. Minus a negative is plus a positive. So y plus 3 equals -1x. -1 times -1 is +1. I go ahead and subtract 3 on both sides. I'm going to move over here because I'm running out of room. Y equals -1x, or just -x, minus 2. That's the equation of the median. Again, you could plot the points as going through A. My midpoint, if I went -1 over 1, -1 over 1, I should hit my median, and I could draw the line. That's the equation of the median, which we've drawn right there. Okay? From here, the very last example is this one asks you, or it tells you the vertices of triangle ABC. So I'm going to go ahead and draw those in. Triangle ABC, A is at -6, 11. B is at 6, -3. And C is at -2, -5, right there on the line. I'm going to go ahead and connect those and form the triangle. Okay, and I can label my points A, B, and C. It tells you that D is the midpoint of AC. Well, if D is the midpoint of AC, I'm going to use rise over run, and I would rise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. So I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Come over. This is going to be my midpoint, which it told us is point D. Okay? So if our midpoint of AC is D, and E is the midpoint of AB, well, E, I can tell you, you can do the same thing. We would count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 to get in line with A. So I'm going to count up 7, 1, 2, 3, 4, 5, 6, 7. It's going to be in that line. This is point E, and our mid segment is DE. Okay, now it tells us since E is the midpoint, then I know that AD is congruent to DC and AE is congruent to AB. Okay, from here we're trying to show that DE is parallel to CB. Well, to do that we need to find the slopes. So the slope of DE, which we can use rise over run, would be, I count up rise 1, run 1, 2, 3, 4. So my slope is 1 over 4. The slope of CB, we can do the same thing. Rise up 2, run 1, 2, 3, 4, 5, 6, 7, 8. This would be 2 over 8, which simplifies to 1/4. Since the slopes are the same, then that implies that DE is parallel to CB. Okay, that's how you could prove that. From here, I'm going to go ahead and erase these markings. And we want to show that that DE equals half of the length of CB. Well, what we need to do for this part right here is we need to find the lengths, okay? So for that, we want to find their length. Now, you could use distance formula, but it kind of takes a while, right? So what I'm going to advise you to do is draw these triangles. Isn't this right here a right triangle? That's right triangle, DE, and then an ordered pair, right? So I'm just going to go ahead and label that. That's D, E, and that's just some random point, but it makes a right angle, okay? Well, I know that when I'm going to go ahead and group these. If you were to put this back on here, we know that the length from D up to this point above it is 1 unit, right? So I can come over here, label this is 1 unit. From this point to E, we can see is 4 units. So I can call DE x and use Pythagorean theorem. 1 squared plus 4 squared equals x squared. 1 plus 16 equals x squared. 17 equals x squared. So the square root of 17 equals x, which means that DE, the length of DE, is the square root of 17. Now, we can do the same thing for CB. Form a triangle. And we can see when we're using these grid lines that this always forms a right triangle. So if I were to pull this off to the side, I know that this is some point, this is C, and this is B. Okay, and I know that that's a right angle. Well, from C to this point is 2. That point to B is 8. Let's go ahead and call CB y. So 2 squared plus 8 squared equals y squared. 4 plus 64 equals y squared. 68 equals y squared. Square root of 68 equals y. Now I can simplify this and say 68 in the house, divide out at 2 and I get 34, divide out at 2 and I get 17, 17 and 1. So I know that CB or y equals 2 square root of 17. Those pair of 2's can come out. Well, from here I can say, okay, if DE is half of CB, well, DE is square root of 17 equals half of 2 square root of 17. Well, these half times 2 is just 1, so square root of 17 equals square root of 17. You're done.